Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a multiple choice question 19 extracted again from 2018, time zone 2 in May, right? It is asking for which factors below can affect the rate of a reaction. Another super typical question that asking for factors, right? Pretty direct and straightforward, right? So remember, when asking for factors about the rate of reaction, we should have some basic concept behind that. In the IB syllabus, the factors will go to the first one, which is the concentration of reactant, right? Remember, only reactant will be meaningful. Any factors about product is meaningless in affecting the rate of reaction if it is going to be forward reaction. Make sense? So number 2, which is the temperature. Because temperature affecting the kind of kinetic energy concept, so affecting the frequency of collision, right? And the third one is going to be the surface area of solid reactant. Again, only reactant is meaningful, right? And exposed surface area is also really important for solid, as normally question can describe it as like using granule versus powder form, and in fact powder form should have a faster rate of reaction. Make sense? And finally, the fourth one, which is concerning about the addition of catalyst, right? Because catalyst providing an alternative pathway with a lower activation energy, so that's why more particles can have sufficient energy to overcome the barrier, so triggering the reaction. So this is the work done by catalyst, right? So that's why with this concept behind, let's check, right? The first one, particle size of solid reactant. True, that solid reactant, right? Okay, and then particle size, right? Normally, the word surface area is not being given directly, but now they will be packaged in a way that they will translate the meaning of surface area to the concept of size, right? Because smaller the size means the bigger the exposed surface area. So that's why obviously true for the first factor. Secondly, concentration of the reacting solution, obviously true because this is exactly meaning the concentration of the reactant in a solution form. True. Finally, is about the pressure of the reacting gas. Remember, whenever it is going to be a gas, the concept of pressure is simply means concentration, equivalent to the ideas of concentration. Why? Because if you can imagine, like increasing the pressure of a gas simply means with a fixed number of space, we add more gas particle. So that means with a finite space, the density of the concentration of the gas particles is going to be increased in order for the gas to exert an increased pressure. So that's why increasing pressure simply implies that at that time the density of the gas particles is going to be higher. So simply means the concentration is going to be increased or decreased, right? So that's why pressure is also going to be a factor that has a large equivalent meaning as concentration of reactant. So that's why pressure of reactant gas is also a factor that can affect the rates of reaction. So that's why the answer for this case will be D.